Okay, so we start with inequality. So x plus 1 divided by x squared plus 1. Then this should be less than or equal to 1 over x. That is inequality. Shift this to the left hand side, you have x plus 1. You can't what? That's your network, I think. X squared plus 1. You shift this to the other side, it will be minus 1 over x, less than or equal to 0. Mute your mic. You are walking, you are disturbing your friends. Mute your mic. Mute your mic. So the common denominator is x squared plus 1, like that. So this one here, I'll have x times that, I'll have x open brackets x plus 1 minus 1 x squared plus 1, like that. This is less than or equal to 0. I've stopped sharing my screen. Are you sure? So x times x is x squared plus x minus x squared minus 1. Divide this by x squared plus 1 less than or equal to 0. Up to this point, any problem? Mm-hmm. It has changed. Here it was positive. There is minus here now. Why? Why? No, no, it's not like that. The sign only changes when you are dividing it by negative. So you're okay now? We can continue. So the next thing I'm going to do on top here, I can clearly see that this nigger and this nigger can go. I'll remain with x minus 1 on top. Down part, I'll remain with this. Less than or equal to 0. The reason why I'm not expanding the bottom part, because I'm not expanding, because I'll just get the way it is and then I find the value. So I'll get the numerator, which is x minus 1 less than or equal to 0. So for x is less than or equal to 1. That is my first critical point. The next thing I'm going to do is I'll get the bottom part, which is x open brackets x squared plus 1 less than or equal to 0. What does it mean? What it means is that x, I don't have space. Can I get rid of which part? Can I get rid of this part here? I want to create space here, and let me move this part here. I move this part. So what I'm going to do is, now x is less than or equal to 0. I also have x squared plus 1 less than or equal to 0. I've just gotten this equal to that, less than or equal to that. Have you seen? So I'll have x squared plus 1 less than or equal to 0. Shift 1 to the other side, x is equal to less than or equal to neg 1. You can't square a number and get a negative. It's not possible. So for this one, no solution. You leave it there. Then you only have two critical points, this and that. Before I use the table, ask me.
So for the question,
Please ask.
at the beginning, when we were starting, when we moved the 1 over x to the other side, after we multiplied, wasn't the final answer supposed to be x plus 1 over x multiplied by x squared plus 1?
Yes.
Was right written x minus 1?
Which part, Mama? I think I'm lost there.
Why is written x minus 1 over x multiplied by x squared plus 1? For the top part, was this supposed to be x plus 1?
I didn't put x plus 1. I had. What did I put?
I'm saying, wasn't this supposed to be x plus 1 on top?
Which you are talking about? This one?
No, the other one, the one in red.
Or you are talking about this one?
Yes.
No, it's negative because we had a negative somewhere there. Now I've deleted this now. Okay. Okay. The best thing what we should be doing is that when you put a question there and then ask. Is that okay?
Okay.
Yeah. Because when you now like the way you have asked, I need to go back, which is not possible for me to go back. But I know because we had this, we had negative x open brackets x plus 1 like this. So this and that it was x squared. This and that is negative what? It was negative x. I don't know if we had something like this. It was negative 1. You're supposed to ask there and then, guys. So now you are making me to go back now because I don't know what you're talking about. I shift this, we are saying is this, right? So I have x, then x squared plus 1. On top here, we are going to have x open brackets I'll have this minus 1 open bracket x squared plus 1. Which negative are you talking about? Which positive are you talking about? Because this time this is going to give me x squared then plus x, not so, and then I'll have minus x squared again minus 1. Which positive, Mama?
Oh, okay.
So what I did was so now when you have got a question, when we roast there and then, don't wait for us to finish because we're going to be wasting time. You ask there and then. Is that okay? So these two they will go. I'll remain with x minus 1 there. Then I'll have this. So I'll have the top part is this. X will be equal to less than or equal to 1, like that. The bottom part is like this. So you get this less than or equal to 0. Again, what is in the brackets, like that. So you can't square a number and get a negative. That's why I said for that other one, it has no solution. You leave it. So you do this. You show them, even if it's up, they'll even question you. This guy, this lady, she failed, but again, why she's giving us this statement? Have you seen this? Then you say for this one, no solution. You leave it there. Then you say the critical points which I have is that x is equal to 1 and x is equal to 0. Only for that and that. Then you use the table. So use the table. So 0 here, 1 there, 2 neg 1 neg in between here half. So if I shift this to the other side, it will be x minus 1. That will be just x, because x plus 0. So if you want, you can get the fraction which we had, which was this, to put it on the down part there. If you want, you can get this part here. You say x minus 1 divided by x, open brackets, x squared plus 1, like this. You can put it down here. If you want, you can just take this and that, you put them down, you choose. You understand? So I have x minus 1, x open bracket, x squared plus 1, like that. If I put negative 1 here, it will give me what? Negative. Negative 1 there, negative overall, positive. Negative 1 here, positive, or negative, sorry. I mean, if I put half here where there's x, I'll get a negative. Here, positive. So I'll have negative. 2 there, positive. 2 there, positive. The overall positive. The first question was less than. You follow the first one. Less than. You get the part giving you negative. This is not the solution. That is not the solution. The only solution is that box. So the solution set is equal to, since it is less than or equal to 0 included all the way to 1 included. As simple as that. Unless you have got questions for that type of inequality. Any questions so far? Hmm?
No.
Okay. Please.
What of the two table? Two table. And the solutions, are we supposed to interpret them?
I don't know that method. I just see people using that method, so I can lie. I feel like this is the best method. I don't know about the Purity. Are you here? I think Purity can teach us the one for using two tables. She's not here. I don't like hard stuffs. That's why I don't even take time to look at that method. You get my point, eh?
Yes, sir.
Yes. But this is simple, I think. Check out the question for 1120, which is likely to come, is the one for modulus. Check out the inequality which involves modulus. Especially the question similar to the question which came in test. Is it test 1 or test 2 for math 1100? That type of inequality. You need to know it. Okay. Let's try to solve this. Should I be moving step by step? Okay. F of x is equal to 3, the modulus of x minus 2, the modulus of x minus 1, or plus 1. The question is, let that be the function. Redefine the function by removing the modulus. They didn't talk about the sketching, but we will do both. Anyway, I know sketching, you know, because that quiz I sent you, I saw some answers. You were able to sketch, but for those who didn't submit the answers, I don't know if you are busy or not. I don't know. Redefining this, the best way you can do this is do this one alone. The answer you're going to find, do it times 3 outside. What do I mean? So you say this is going to be you get what is in the modulus, like that. The condition is that if for the positive part you get that greater than or equal to 0, again you multiply by negative, which is going to be what? You have to get the positive part. The first one is going to be greater than or equal to 0. We have been doing this for redefining. The second part I need to do times negative, which is going to be negative x plus 2. The condition is the same, but I put less than 0. So for x, if I solve for x, x minus 2 greater than or equal to 0 is going to be x greater than or equal to 2, meaning that other one is going to be x less than 2. I'm waiting for someone to tell me that Fasa, you are very fast. 2 negative x plus 2. The condition that x less than or equal to, or less than, just less than 2. Now do for each guy times 3, because there is 3 outside here. So you do this: 3 open brackets x times 2. The condition is the same. Again here, 3 open brackets negative x plus 2. The condition is the same, less than 0, like that. So our overall answer for just defining the first part is going to be 3, the modulus of x minus 2 will be equal to you're asking about, again you are doubting your question, because the question is not true answer. Hmm? I'm just writing it. Are you, so you are not behind here? So I'm just writing that. So 3 times that one, it will be 3x minus 6. You have seen? Another one to be negative 3x plus 6. The condition x greater than or equal to 2. This one x less than 2. Another one can say do you understand the fact that if I have this is the same as the modulus of 3x minus 6? I've just multiplied this and there, 3x 6. It's the same. If I solve for x here, still I'll have x to be equal to 2, because 3 divided by 2, it will be, I'll have the same thing. So you choose either to do it direct, you multiply it by 3, then you have 3x, the modulus of 3x minus 6. You choose. Not that they just put a number there. No, the one you taught us. I remember this question. It was test 2 for 1120. Before test 2, I taught these guys for 1120 how to redefine a function. Then they just included these 3. Then they came in my inbox and started crying. No, you didn't tell us when there's a 3 outside, when there's a number outside. No, we just do this times that, this time that. So we have redefined the first part. Now allow me to create space. Mm, mm. Okay, initially we are multiplying this by plus or minus x minus 2, like that. So the first part, when you do plus, when you multiply it by positive, you put greater than or equal to. When you multiply it by negative, you put less than. You okay there, mama? You're not responding again. So x plus 1, I want to redefine that one. It will be, the positive part is that x plus 1 is greater than or equal to 0. The negative part will be negative x minus 1. I'm just doing it direct because I know that we have been doing this for some time now. I'm just multiplying this by a negative now. Everything inside there by the negative. Negative times x is negative x. That's why here I also have negative. The condition is that the same guy less than 0. Okay? So I'll have x plus 1. The condition is that when I solve x here, it will be x is greater than or equal to neg 1. The other one will be x less than neg 1, like that. So x greater than or equal to neg 1. Another one will be like that. It is minus 1. Then the condition x is less than neg 1, like that. So I have redefined that other one. Wish I can put it here. Where should I put it? Because of space, x plus 1, like that. I have redefined it. So you have to put this on the table now. You have to put this on the table. What do I mean? You have to put this on the table. Today, this is when I'm going to explain. If you didn't understand redefining, this is your chance now to understand. You miss it here. If you miss it, meaning you're not going to do it. You are clearing up, so you are not going to be doing math. So it's not even important, even if you miss it. So you put here the modulus of x, the modulus of this. Again, I put the modulus of x plus 1, like that. So what we have to do now is we put the numbers. We have got 2 and negative 1. I'll put neg 1 here. I'll put 2 here. Get me clearly there. Here, just say x is greater than, you do this. Let me first show you this. The numbers from 2 going to this side, are they greater than 2 or what? Or less than 2? They are greater than. Now, here the only guy which has got 2 is the first part here. This one. So we're talking about greater than 2. So you get the sign which is there. In this case, is x is greater than or equal to 2. Have you seen? So x is greater than or equal to 2. I'll put it there. Then now when I start from negative 2, the numbers from here going this side, are they greater than negative 1 or less than negative 1? Ella. Less than. So I'll get now. If it's less than, which one is talking about less than here? Is this guy here, which is just less than, not less than or equal to. So I'll say x is less than negative 1, just like that. This negative 1 will represent that one. Now I'm remaining with two things. I'm remaining with this one and also that one. So we know that in between here we are talking about a number which is greater than or equal to negative 1 but less than 2. So I'll put x in between, then I choose. Okay, this one is telling me that x is greater than or equal to negative 1, so I'll put it like that. Then this one is telling me that x is less than 2. I'll put this one here. What does it mean when I say negative 1 less than or equal to x less than 2? What does it mean? X is greater than or equal to negative 1 and x is less than 2. I'm done with all the condition. I've used that, I've used this, I've used this, I've also used that. Any question there? You are having problems on how to get these guys in between there. Energy, that's it up, I mean up. We are done with this part. X is less than negative 2, which is this part. I have used that part already. I'm no longer interested now. X is greater than 2 is this one. I've used it, which is that one. I'm remaining with the one which I'm remaining with is this part I'm highlighting here, and also that part here, which is x is greater than or equal to negative 1 and x is less than 2. So in between I have got negative 1 and 2. So the condition is that I have got x should be greater than or equal to negative 1, which is this part only. I'm done with that part. At the same time, x is less than x is less than 2, which is that part. I'm done with those two. You need to know to write. Do you know that x is greater than 1 is the same as 1 is less than x? So if you don't know about that, you will know today. X is greater than 1 and 1 is less than x. It's the same. When you do this, the next thing you are going to do is you start now. For the first part is this one here. Okay? Which condition is telling us that x is less than negative 1? Which one between the first one and the second one is telling us that x should be less than negative 1 in that case? Is it the first one or the second one? The second one. So I'll put the second here. 3x plus 6. Like that. I'm done. Have you seen what I've done? Okay. Then I'll go to the next one here, which is that one. Which one is telling me that x is less than negative 1? The second one. I'll also put the second one. Negative x minus 1. Like that. I'm done. I'll go on the middle. On the here, when I'm talking about the first part here, I'm only interested in 2, not negative 1. So I only concentrate on this part here because I only have 2 here. So I'll say which one is telling me that x is less than 2? It's the second one. I'll put here. When I come here, meaning I'm talking about the second one, I'm now interested in what? 1. So here we have got negative 1 less than or equal to x, which is x is greater than or equal to negative 1. Which condition is that? The first one. I'll put the first one here. X plus 1. I'm done with the middle. I'll go to the last one. I'm interested in 2. So for the first one, which one is telling me that x is greater than or equal to 2? Is the first one, which is 3x minus 6. The second one, which one is including 2? When I say x is greater than or equal to 2, meaning it's the first one.
Someone in the message is saying that you're too fast.
The problem is that when I'm going to mwasolva pakatenti series echeyi solani first, but those who are following is fine. Let's continue following. Those who are following, let's finish this one because I can't start again, meaning it's going to take 30 minutes. Moreover, this is coming for 1100. For 1120, it's a red flag. So here we go. So uh, uh, so for 1100, for 1120, this is a red flag. But it can come. Unga dab so. But pass on 6 marks. I dab or no dab. So
You're even laughing at that.
I'll go. So I'll go to the next one. The next one, I'm talking about the second part. The second part, which one is telling us that x is greater than or equal to 2? Is the first part, which is x plus 1, like that. Okay? Then now I need to add these niggers. Okay? I'm no longer interested in that. I need to add them. Funsan chabe boss. just ask. This is the only math I know. I can even repeat 10 times, but it's going to be hard for you to understand. Okay, but some of you, not all of you can understand this concept, but some are going to understand. That's why there is choosing, you understand. So here what we're going to do is this. I'm going to add this. Okay, let's just be fair. Any question here? Who is Rost?
Yes. No, I've got a question.
Please ask.
I thought maybe we follow the same, just like in the whole question. It says this equation, the modulus minus this modulus.
mm,
So that
yes,
doesn't
I'm
mean
going to,
we add.
okay, the principle is the you follow this one. When I say add, but I knew to say I'm going to put minus because I'm supposed to say this minus that. So I'll be saying this minus that because I'm going to be putting them in the brackets. That's why I said we add this, but it's fine. You can follow that to say no. We are following the sign which we have been given. Is that okay?
Yes.
Another question.
Yes.
Another question.
No.
We can't waste time here. So now we'll say negative 3x plus 6. Okay? I put them in the brackets. Minus. Again, minus this chap here down. So minus x minus 1. The condition is that x is less than negative 1. In between, I have got negative 3x plus 6. Then minus, in the brackets, I have got x plus 1. Then the condition is that negative 1 less than or equal to x less than 2. The last one is 3x minus 6. You put them in the brackets minus x plus 1. The condition that x is greater than or equal to 2. Like that. So the final answer will be, if I open the brackets there, I'm going to have what? I'm going to have negative 3x plus 6 plus x plus 1. The condition is x is less than negative 1. In between, I'll have this. So sad that I'm too fast because I'm just copying here. I'm not doing anything. Have you seen what we were doing? So the final answer will be this, and this is going to give me negative 2x. 6 and that, it will be plus 7. The condition that x less than or equal, no, less than negative 1. Then here negative 3 and that one negative 4x plus what? Plus 5. The condition that negative 1 less than or equal to x less than 2. The last one is 3x and that one, it will give me 2x minus 7. The condition that x is greater than or equal to 2. This is the answer. You have redefined this by removing the modulus. How do you report the answer? When you do all these tasks, but you show all this. When you don't show it, they will assume that mwezoshuta she boss. So I'll put this here. I'm done. If they say sketch, you follow the principles. We know how to sketch this. Okay, let's do one radical equation. Just one. We are just sampling out. 1 plus the root of ah, this question was hard. 1 plus the root of 1 minus x is equal to the square root of 2x plus 4, like that. So the question is, find all the real values, or find all real valued solutions to the equation this. The first thing here, what we can do is we can just square both sides. Now, what if I've got a question which is like this, plus the root of maybe x squared minus 1 is equal to 2. At this point, I can't square direct. I need to shift this side, this guy, to go to the other side. What do I mean? I need to have a square, a guy which is having a square root to the other side, and also to the other side I need to have a square root. Then I can square. I hope you have gotten my point there. If I've got equation like this, I can't square direct. I need to shift one of these to go to the right hand side. Is that okay? Now that this is not modulus, I'm going to move slowly but sure. So we'll start. 1 times 1 is 1. 1 times the square root of 1 minus x is 1 minus x. Then again, this times that, I'll get plus the root of 1 minus x. Again, this times itself, I'll get plus. Then since this is plus, that's why I can just do it there. But if there was minus here, guys, believe me, what I'm supposed to do is, but anyway, it's going to be the same. It will be 1 minus x is equal to, here I've got 2x plus 4. Any question? Any question, please? No question. These two can be added. Again, this and that can be added. So I have 2 plus 2, the root of 1 plus minus x is equal to 2x plus 4. Now I only have one square root. So you can mute your mic if you don't have a question. So I can shift. I've forgotten one x here. See the sign that no one is following. I can shift this and that to the other side, which is going to be 2, the root of 1 minus x is equal to 2x plus this x now, plus 4, then minus 2. I've shifted these 2 to the other side. 2, the root of 1 minus x is equal to this and that, 3x plus 2. Any question? I'm now slow, right? Let's now square. If I square this, I'm going to have 4, open brackets, 1 minus x, like that, is equal to 3x times 3x, 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x, 6x. 2 times 2, 4. 4 times 1, 4. 4 times x, 4x. 9x squared plus 12x plus 4. I'm saying if you don't have a question, you can mute your mic. Job 13:13. I have a 4 here. I have a 4 there. I can cancel them. Brown. Okay. Let's shift everything here to the right hand side so that we remain with 0, because this is a quadratic equation. X squared and x is appearing here again. 0 is equal to 9x squared plus 12x plus 4, then plus 4 minus 4. This is 4. You are now following, which is good. 0 is equal to 9x squared plus 16, x. Then what? What else do we have? 0.
Nothing, that's all. Just zero.
Allow me to rewrite this here. 9x squared plus 16x is equal to 0. Get me clearly here. If I had a number, if maybe this was x squared plus 16x plus or minus any number here, I would have said this is a quadratic equation. I use the normal way, the way we are finding quadratic equation. In this case, I don't have any number there. I'm going to factor out x. I'll say x open brackets 9x plus 16 should be equal to 0. Have you seen what I've done?
So x should be equal to 0. Then 9x plus 16 will be equal to 0.
Exactly. So x will be equal to 0. 9x plus 16 will be equal to 0. So 9x is equal to negative 16 divided by 9 divided by 9. So we have x to be equal to negative 16 over 9. I have two values of x. Now, this is what we call a radical equation. When you find a radical equation, after finding the answers, you have to prove it if it's going to give you the correct answer. So at this point, we call it, we're going to have extraneous answers. We have solved that they are part of the solution, but in actual sense, they are not. You end here 0.
Even one mark.
0. 0. In fact, negative. In fact, negative 10. Now, if you end here, if the question is maybe, let's say it's 5 marks, they can give you maybe a 2. So let's start now putting the values. If I put here, it's going to be 1. If I put 0 here, it's going to be 1. The square root of 1 is 1. So I'll have this. 1 plus 1 is 2. The left hand side, I'm getting 2 when I put 0. Again, the right hand side, I'm getting 2, right? Because 2 times 0 is 0. 0 plus 4, so I have there. Therefore, this is the correct solution. Now, we also put this one here. So we have the right hand side. Guys, if you have got time, go and put this. If it's going to give you the same, then that is the solution. Me, I don't have time. So you put negative 16 over 9 because you are going to have 3 hours. But in this case, we don't have that 3 hours. If it's going to give you the same answer, this side and that side, then it's also part of the solution. If it's not going to give you the same, then it's not part of the solution. Then you say the only solution is the one which is giving you the same, both left and right hand side. Let's have a 5 minutes break for just drinking water. 5 minutes break. So you not a nap. Takuri kunaka boss. Now I told you to drink some water. If you have not taken water, that is your own issue. Me at least I've taken something. So let's continue. Now let's talk about binomial. The first question I have here is find the term independent of x in the expansion x minus 1 over x all the way raised to the power 12. Let me read the question again. Find the term independent of x in the expansion. Okay, this is coming. Now, a term independent of x, if I give you this 7x plus 10x minus minus 7, meaning that a term independent of x is this negative 7 here. We know that this is the same as x to the power 0. Any number to the power 0 is the number itself. Okay? No, any number to the power 0 is number itself. No, any number to the power 0 is 1. So like in that case, that's why it's just 7. So what we have to do is we use the formula using binomial theorem. Okay. So a plus b raised to the power n is given by the formula n choose r, a raised to the power n minus r, b to the power r. You need to know this formula. It's very important. In this case, a is x, b is negative 1 over x, n is 12. We don't know r. Our goal is to find the r. Now, how can we find r? There we go. We'll say x minus 1 over, like that, raised to the power 12 is going to be equal to, now I'm going to say n. Now in this case n is 12, r I don't know r. The next thing I'm going to write a is x in this case, but this x should be raised to the power n minus r. N is 12, I'll put 12 here, minus r, like that, times b is negative 1 over x raised to the power r, like that. But I'm interested to find r. What am I going to do? I know that I need to concentrate on what? X part. When I get the x only, I need to equate those x equal to x to the power 0. Meaning that the bases are going to be the same. I'll cancel the bases. I'll equate the powers equal to each other. What do I mean? Ignore this negative. Even if you have got a number here, maybe we had 2. Ignore that number for now. Okay? I'm only interested in x because I want to find r. So I have got, this is the same as this part here. I can write that one to be the same as negative 1 times 1 over x. So now 1 over x is the same as x to the power negative 1. Do you know that? If you don't know, today you should know that 1 over x is same as x to the power negative 1. You understand? So the next thing what I'm going to do is, I'm going to get this x only to the power 12 minus r to be times this. This now is going to be x to the power negative 1. But outside there I've got r. So I'll say negative 1 times r. I'll get negative 1r, which is the same as just negative r. This has to be equal to x raised to the power 0, because x to the power 0 is a term independent of x. Before I continue, any question? Before I continue, any question? I repeat what? When you go to the hospital, you are sick. Okay? You want to meet the doctor. The doctor is asking you, okay, Betha, what's wrong? You are sick. Yes. Okay. What's wrong? You can't say the whole body is paining. They can't give you any medication. You have to specify the, okay, I'm feeling my shoulder here is giving me problems. Okay, here I've got a problem. So where exact? You can't say everything. Which part? Tell us.
For me, when finding the
We have not gotten R here. We are there. We want to find the R. So what do you mean when finding the R?
negative 1, where you put negative 1 multiplied by 1 over x.
Do you know that if I have got 2 over x, do you know that this is the same as negative 2 times 1 over x? Isn't it the same?
Yes.
Yes, so that's what I've done here. I've gotten this negative to be just that one, then 1 over x to be that one. But it's not even necessary to do that. But what I was just trying to explain to you that you ignore this, then meaning that if I ignore negative 1, meaning I've got 1 over x. But now if I want to write that x to be in the same line with this one, that's why I've said it's x to the power negative 1. Now that negative 1 times r is negative r, which is here now. That is okay, right? Yes, so now we are supposed to say, sir, I'm not okay that part. I'm not okay with everything. No, we can't give you medication in that case. So thank you for understanding. Let's continue. Now the powers, when the bases are the same, we add the powers. In this case I'll say x, then the powers I add them, 12 minus, so I have got 12 minus r, again minus r, to be equal to x to the power 0. So that is going to give me x to the power 12 minus 2r to be equal to x to the power 0. Up to this point, who is behind? I've just added the powers here. So at this point, you equate the powers equal to each other. So it will be 12 minus 2r is equal to 0. Solve for r. So it will be negative 12. Negative 2r is equal to negative 12. So divide both sides by negative 2. Both sides by negative 2. R is equal to 6. I have now my r. Believe me, we are finding a term independent of x. When I plug in r here, the x values are going to be cancelled out. That is what we need to know. Very, very important. If you plug in this r in here and you discover that they don't cancel out, meaning your r is wrong here. Okay? Meaning now I'm not interested in this part here. I'll go back to my original formula. I start now replacing my r. So I'll say 12, choose r. R is 6. Okay? So I'll say x raised to the power 12 minus r is 6 times neg 1 over x, r is 6. So it will be 12, choose 6, like that. Then this is going to be x to the power 6 because 12 minus 6 is 6. Is 6. So here I've got negative 1 raised to the power 6. What is negative 1 raised to the power 6? Positive 1. So I'll have positive 1 over. Then x raised to the power 6 is x to the power 6. You know that, right? Yes. The next thing I'm going to have, guys, is this. Let me get rid of that part. I'll say 12. I'll say 12, choose r. R is 6. So I'll have x raised to the power 6 times 1 over x to the power 6. Have you seen that this will be indeed a term independent of x? This nigger and that nigger will go. So I'll have now 12 choose 6 times what? Just 1. Which is the same as just 12 choose 6. So this is the same as 12 factorial over 12 minus 6 factorial 6 factorial. So I'll say down part I'll have 12 factorial, 6 factorial, and 6 factorial, which is going to be 12 times 11 times what? 12 times 11 times 10 times 9 times 80 times 7 times 6 factorial. Down part here I'll have 6 factorial, then this one will be 6 times 5 times 4 times 3, 2 times 1. So 6 factorial and 6 factorial can go. Are we okay there? Before I start now dividing. 6 here, 1. 6 into 12, 2. 2 into 2, 2. 2 into 2, 1. 2 into 2, 1. That 2 has gone. Let's go to 5. 5 into 5, 1. 5 into 10 is 2. Next thing, I'll have what? I'll have 4. 4 into 4 is 1. 4 into that one is 2. Next thing, I'll have 3. 3 into 3, 1. 3 into 9, 3. The top part, I'm done with the bottom part. The top part, I'm remaining with 6. 11 times 2 times 3 times 2 times 7. A term. Are we together there? A term independent of x is when I multiply that. Now, since it's not me who is going to write exam, I'm going to use a calculator. But you are not supposed to use a calculator, please. So it's 11, but let me not use a calculator. You might think maybe I can fail to multiply this. 2 times 11 is 22. 22 times 3, 66. I'm done with this part. So I have got 66 times 2 times 7. If you think I can't use a calculator, I can do this. So I'll say 2 times 6, 12. 2 carry 1. Yes,
I have a question.
please ask.
That 2 there, like divided by 2 multiplied by 1, which is under, you cancel the 2 out with 1.
These 2 here,
Yes, that 2.
I cancelled these 2 with that 2 which was there, because here we said it was 12, so I did 6 into 6 1, 6 into 12 2, so I'm remaining with 2 here. 2 into 2 1, 2 into 2 1.
Okay, sir.
So we are saying 11 times 2 is C, 22. 22 times 3, 66. 66 times 2, na jam up. So I'll say 12, 2 carry 1, then again 12. 12 plus 1, 13, 132. I have 132 times 7 now. So 14, 21, 21, 22, 2 carry 2, 7, 9. So a term independent of x is 924. Unless you have questions. Any question, guys? Any question? No question.
No.
Let's go to the next one. Let me first write the question. 1 divided by 1 plus 2x. 1 minus 2x. Let me read the question for you. Use binomial expansion to express 1 over 1 minus 2x as a series up to and including the term x to the power 3, and state the range of the values of x for which the expression is valid. Let me read the question for you again. Use binomial expansion to express 1 over 1 minus 2x as a series up to and including the term x to the power 3, and state the range of the values of x for which the expression is valid. When you hear that they want us to expand all the way to x to the power 3, you use the formula. I've forgotten that formula. Can you tell me? That formula, we are saying it is 1 plus what?
Plus
Plus nx plus n open brackets n minus 1 x to the power 2 divided by 2 factorial plus n minus 1 n minus 2 x to the power 3 divided by 3 factorial, because I'm ending on x to the power 3. This is the formula we use. Now what we have been given here is the same as 1 minus 2x raised to the power negative 1. Do you know that? In this case, our n is negative 1. Our x is negative 2x. We go, right? So 1 plus our n is negative 1. X is negative 2x, like that. Plus our n negative 1. Then again neg 1 minus 1. X is neg 2 x to the power 2. Divide this by 2 factorial. Plus, again here I'll just follow the same thing. My n is neg 1. Neg 1 minus 1. Neg 1 minus 2. Then x is negative 2x raised to the power 3. 3 factorial. Before we continue, any question, any queries? No questions, right? So 1 plus is not going to be plus. Because of this negative, no, it's going to be plus. Negative 1 times negative 2x plus 2x. So here I'm going to have this negative, and that negative which we're going to have there is going to be what? I'll have negative 2 inside times that one is going to be negative 2. Then again I've got this one, if I square it, it's going to be positive 4 x squared, like that. I divide this by 2 factorial plus, here I've got this, and this is going to give me negative. Isn't this going to give me positive? Positive, yes, thank you. So I have now positive 2 times negative 3, which is negative 6. This is going to give me negative 2 times negative 1, positive 2. Positive 2 times this, and this is negative 3. Positive 2 times negative 3, negative 6. Negative 2 raised to the power negative 8 x to the power 3. If I've not made a mistake, everything 3 factorial. Please ask.
Yes. Back to the one which has the 2 factorial down.
Sure.
Yes. Isn't that supposed to also be a positive 2?
Okay.
When we say
Oh yes, we say it is positive. Yes, it's positive. I included positive. I don't know how. I think the time you started asking, then positive ya disappear. I don't know what happened then. Yes, so it's positive. And then this one can go. Okay, so I'll start now writing here on top. It will be 1 plus 2x. This times that one is going to give me plus 8, plus 2 8, then plus 8, not so, guys. 8 squared divided by 2 minus, again here is going to be plus because of that, 6 times 8, but let's just put it like this. Let's just put it 6, then times 8, then 8 to the power 3 because of this guy here. So I have 3 times 2 because 3 factorial is 6, not so. So I have 1 plus 2x plus 4x. This there, 2 will go there, plus 8 x to the power 3. This is my answer. Here is supposed to be 2. Any question? So state the ranges of values on which this is going to be valid. What did I say last time? You get this, the modulus should be less than 1. The best thing here to work out this one is, I said, just get what is in the square root, in the modulus. So for x, equate it equal to 0. Just say 1 minus 2x is equal to 0. So for x, negative 2x, it will be equal to negative 1. Okay? Divide both sides by negative 2, like that. So what are we going to do? What are we going to do? X is equal to 1 over 2. So what you do here is this. You start this one with a negative part. You say it will be negative 1 less than x less than, then positive that. Positive what? Positive 2. So this is the range of values on which this is going to be valid. Do you understand the fact that this is the same as we say x is greater than negative half and x is less than half? You know that, right? So I have another question here which I know it can't come, but we can just waste time. The question is, using part 2, the one we are solving, find the approximate value of 1 over 0.98, giving your answer correct to 5 decimal places. Do you want us to waste time?
no.
Let me tell you, if this question comes, what you are supposed to do, even if I explain, can't come. Okay, we move The remaining parts of binomial, this is the main thing, but the remaining part of binomial, please try to go through the remaining part. Those my nth term, those are basics. Try to go through. So for binomial, I rest my case. There is a question which always come. The question is, the polynomial p of x is equal to 3x to the power 2. Let me put the question here. The polynomial p of x is equal to 3x to the power 2 minus 2x squared plus px minus q is divisible by x minus 1. Okay, is divisible by x minus 1 and leaves a remainder. The remainder which is going to leave, if it is divisible by x minus 1, the remainder will be 10. Then again, they are saying that it can also be divisible by x plus 1 and leave a remainder of okay, just a minute, let me just read the question again. The polynomial p of x is equal to 3x to the power 3 minus 2x squared plus px minus q is divisible by x minus 1 and leave a remainder of 10. They are also saying when divisible by no, I'm not reading the question correctly. So they are saying this one, when it is divisible by x minus 1, is divisible by x minus 1, meaning the remainder there, they are not mentioning anything about the remainder, meaning the remainder is what? 0. Then they're saying and leaves a remainder of 10. So it leaves a remainder of 10 if they divide it by x plus 1. I read the question, find the values of p and q. Should I read the question again? Or you have gotten the question? The polynomial p of x is equal to 3x cubed minus 2x squared plus px minus q is divisible by x minus 1 and leaves a remainder of 10 when divided by x plus c. So it leaves a remainder of 10 when you divide it by x plus 1. So the best thing to do here, you are going to have two equations. So you solve for x. So I will say x minus 1 is equal to 0. X will be equal to 1. When I plug in 1 where there is x, the remainder is 0. I'm going to equate it equal to 0. Let me repeat myself. Get this, equate equal to 0 because the remainder is 0. Not the remainder is 0, no. In that case, we need to find the value of x. When we plug in there, the answer should be, we are going to equate it equal to the remainder. Remainder is 0 in that case. So I'll say 0 will be equal to, I plug in 1. This is to the power 3. Minus 2, then 1, plus p, I put 1 minus q, like that. So I'll have 3 minus 2 plus q minus q plus p minus q. These two, they will give me 1. Here I've got 0. Like that. So p minus q is equal to negative 1. This is going to be my equation 1. Any question? Any question there? No question, right? The next thing is I'm going to get the one leaving a remainder I solve for x. X plus 1 is equal to 0. X will be equal to negative 1. When I plug in negative 1, the remainder is 10. I'm going to equate it equal to 10. So I'll say 3 negative 1 to the power 3 minus 2 negative 1 to the power 2 plus p negative 1 minus q is equal to the remainder, which is 10. So this is going to give me negative 3. This is going to give me negative 2 minus p minus q is equal to 10. So I'll have negative 5 minus p minus q is equal to 10. Negative p minus q is equal to 10 plus 5. This minus this is equal to 15. This is my equation 2. Any question there before we find the values of p and q? Any question? Mazia yayo fyana. So we have P minus Q is equal to 15. P minus Q is equal to -1. Simultaneous equation. I'll use substitution. Let's make P as a subject of formula in any. Let's make P as a subject of formula in the second equation. P will be equal to -1 plus Q. In the first one, where there is P, let's put -1 plus Q. So I'll say negative outside, then P, I have to put -1 plus Q is equal to 15. So it will be +1. We don't put +1. It's +1 minus Q. Here there is plus what? I have made P as a subject of formula for the second part. So plug in where there is P with -1 plus Q there. So I'll say negative, open brackets, -1 plus Q, close the brackets, minus Q is equal to 15. -1 times negative that is going to be positive. Minus Q is equal to 15. So I'll have 1 minus 2Q is equal to 15. Shift this to the other side. -2Q is equal to 15 minus 1. So -2Q will be equal to 14. Divide both sides by -2. -2. Q is equal to -7. Done. We made our P to be equal to that. Plug in PQ with -7. So P is equal to -1 plus Q. Q is -7. Therefore, P is equal to -8. Any question? Any question? I'm done with this. Should we try to work around with calculus? Makwesheni mwezi matuma mbili. Makwesheni mwezi matuma mbili. Boza niwa ipa notika zinamana ya. Question I wrote. Let's talk a bit of did we talk about the sketching of log and what? But we solved one equation for log. Okay, you try to help me by watching that, I think, to my videos for log, because I'm trying to deal with big stuffs here. Okay, because I know that log maybe one question can come. I'm trying to, let's talk a bit of trig. But before that, trig is big. Trig and what? Trig and what? Calculus. These two are big. Okay. Let me. I'll do it under calculus. That's not a problem. There is this question which confused almost the whole generation. G of t is equal to, inabwera pa kasapu kama guys haka. Kasapu keze badi akaboza niyo ipa. Akabana guapo. Stingana mane. T is less than or equal to 4. In between they are saying 10. Then the condition that -4 is less than t, then less than or equal to 15. Then the next one is 1 minus 10t, or 6. 1 minus 6t, the condition that t should be greater than 15. So the question was evaluate each of the following. The first question was g of negative 6. This was the simplest piecewise function I've never come across. So g of negative 6, you check the conditions. These are your conditions. Which one between the three is telling us that x, okay, is including negative 6? Is it the first one, the second one, the third one? Come on. Am I? The second one is including negative 6.
It's the first one. It's the first one.
The first one is saying from negative 4 all the way to positive infinity. It includes negative 6, not so? So I'll get that equation, the first equation, this. Plug in negative 6. Square it. Negative 6 squared is 6. 3 times 36. Three times 36, 108. 108 plus 4. The answer is 112. The next one is find g of 1. Which one is including 1? The first one, the second one? You know, if you don't understand what is happening here, sometimes if you're going to be scared asking, you know, I think for now, I think guys, you are used with me. That's how I am. Sometimes when you respond, maybe you take it as if I'm rude, but I'm not. But I like it when you ask. And you don't have to be scared. If you don't understand what's happening here, tell us. Okay, you are quiet, meaning you understand. So we are going to get it. The answer here is just 10. Because I don't have anything here, just say it's 10. So then the next one, what I'm going to do is I'm going to get, what's the next question? The next question which I'm going to do is saying g of 21. So what is g of 21? Which one is including 21? Is it the first one, the second one, the third one? Let's get the third one. 1 minus 16. So I'm going to put now where there is t with 21. 1 minus this. Like that. So I'm saying 6 times 21. 126. So it's giving me 126. 126 minus that is going to give me negative what? 125. That was the supplementary exam. Those were the answers. Let's have 5 minutes break, then we come back. Trig. I'll just prove 2 identities. I'll solve 2 equations. I'll sketch 3 graphs. Then we are done. So prove the identity, which is, and you have failed to give me interesting questions. That is your own thing. But so I've got this simple equation. Proving. So prove that this plus sine squared theta to be equal to 1 minus sine theta. Even if you don't know how to prove identities, this is the simplest identity I've never come across. No, if I've got a question, just answer. Oh, yeah. Just ask. You're raising your hand, meaning I've got a question. Anyway, so we are proving that the left hand side is equal to the right hand side. So I'll start asking. So I'll say the left hand side is cos squared theta divided by sine theta plus sine squared theta. So for you to prove this, you have to check what you are trying to come up with. I'm trying to prove that that is equal to that. And I clearly know that on top there, I can replace, I know that sine squared theta plus cos squared theta is equal to 1. So cos squared theta can be replaced by 1 minus sine squared theta. So I'll say this is the same as 1 minus sine squared theta over sine theta plus cos squared theta. At this point now, I know that what I have on top, here I need to have 1 minus, sorry. It's a difference of two squares. I can say it's 1 minus sine theta, I put them in brackets, and 1 plus sine theta. If I expand here, I'll come back to this. Okay? The next thing I'm going to do, down part, I'm going to factor out sine. So sine theta will be equal to 1 plus sine theta. Now I can clearly see that this and that can go. I'll have 1 minus sine theta divided by sine theta. So the left hand side is equal to the right hand side. Hence, proved. Any question? Any question?
No, it's clear.
I'm trying to get the question which can come. Let's try to prove this identity. Each question is some total ichi. Ichi singa bwere ichi now. Cham total ichi. They are nice questions. I don't know why you have failed to find those questions from past papers. The equation which is coming is just one though. Let me just show you this one. So the question is, solve the trigonometric equation for tan squared x plus 2 sec x plus 1 is equal to 0. So when you are dealing with this, what you have to do is, first you can change what is sec. Sec is 1 over what? 1 over cos. So I have tan squared x plus 2 in the brackets 1 over cos x plus 1 is equal to 0. So I can write this so that I get rid of what? Tan. I can say this is the same as sine squared x divided by cos squared x. Then I have 2 over cos x plus 1 is equal to 0. Have you seen what I've done? Have you seen what I have done?
Yes.
So I create the same as I've got 1. Let's have the common denominator. The common denominator is cos what? Cos squared x. So this into that one times that one, I'll have sine squared, okay, x plus, here I'll have just cos times that one, it will be 2 cos x. Then here I'm going to have what? I'm going to have 1 into cos squared. 1 into cos squared is going to be cos squared. Cos squared times 1 is going to be cos squared x is equal to 0. Okay? Is that okay? Have you guys seen what I've done? Yeah, so the best thing here, what I'm going to do again is I know that I can say sine squared x plus cos squared x again plus 2 cos x. I divide this by cos squared x should be equal to 0. Now I do know that for me to get rid of sine, I can replace this with 1. So it will be 1 plus 2 cos x is equal to 0. Then here there is divided by cos squared x. At this point I can cross multiply. So here there is 1. If I cross multiply, here is going to be 1 plus 2 cos x is equal to cos squared x times 0 is 0. So I can shift 1 to the other side. It will be 2 cos x is equal to negative 1. Like that. Divide both sides by 2. Divide both sides by 2. I'll have cos x to be equal to negative 1. Then what I have to do is this. What is cos 1 over 2? Forget about the negative for now. What is cos, when I say cos x is equal to half, is what? What is the angle? 60, right?
Yes.
Okay. So it will be x is equal to 60 degrees. But now, the issue which we need to understand is that we are talking about negative. It's negative half. So you check, where do we find cos to be negative? All student take chamba. So where cos is negative, it is in the second quadrant and there in the third quadrant. In the second quadrant, I'm supposed to say 180 minus 60, which is what? 120. Therefore x is equal to 120. It will be my first answer. Another answer in the third quadrant, I'm going to say it is the angle I have plus 180. That's what we said last time. The 60 plus 180. What is 60 plus 180? 200. Not so. 200. Now the question is, find the answers in interval this. Meaning the answers are supposed to be in large. Okay? So I have to convert this now. If you leave it there, 0. So I have to convert this one now to what? To, I'll say 120 times pi over 180. 0 and 0 can go. 6 there, 2 pi. 6 there, 3. So the first answer is that x should be equal to 2 pi over 3, comma. What of 200? So the 200 one is going to be times pi over 180. 0 and 0 can go. 20. I'm dealing with 20. 4 cannot go. Which number can we use? 3, no. 2 there, 10. 2 into 18, 9. So 10 pi over 9. My next answer. These are the solutions. Unless you have questions. The most interesting question which I have now seen is saying that given that sine alpha given that sine alpha is equal to 1 over or 4 over 5. But this can't come. We can just waste time, right? But we can just waste time by solving this. No, this can't come. Let's not waste time. This can't come. Now guys, for sketching you have only sent me one question. I want to focus more on sketching though. Huh? The general equation which you need to know is this. So A is amplitude. You equate this equal to 0. So for X is your phase shift. D is the vertical shift. The period, we find period by saying 2 pi over B. We explained this already. The next thing I'm going to do now is I can now get the question we sketch, like the question we had. The question we had, which I gave you as a quiz and which someone has sent in the group, is -2 plus 3 sine. Can someone find any question for cos? I want us to have one question for cos and sine. Half theta minus pi. Can someone find the question for? So the question was find the period, amplitude, phase shift and vertical shift for the function. They didn't say sketch though, but we're going to sketch, right? So the amplitude is 3. The phase shift, the period is 2 pi over b. B is a number in front of x or theta. In that case 1 over 2. So it is 2 pi times 2, which is 4 pi. That is the period. The phase shift, get what is in the brackets. So for theta, equate it equal to 0. 1 over 2 is equal to 0. So I'll have 1 over 2 theta minus pi is equal to 0. Shift this to the other side. What am I doing now? One over 2 theta is equal to pi. So divide both sides by half is the same as doing times 2. So theta will be equal to 2 pi. That is my phase shift. My vertical shift is -2. Any question on how to find the period, phase shift, vertical shift and the amplitude? I'm saying find the question, not a question gonna bora mu exam yano. Find the question which involve cos. So to sketch this, how are we going to sketch? The best method, guys, to use is the phase shift which you have, which we have said is what? What is the phase shift? Was it pi over 2? The phase shift, that's what we found?
2 pi.
You know why I'm even having challenges, but I solved this, which was question quiz 2. Okay, it's 2 pi. The phase shift is where the graph is going to start from. That's what you should know. So I'll put here 2 pi. Let me be genuine to you. I'll put there 2 pi. So I'll keep on adding the phase shift. You get my point, eh? Until I reach 5 points. So if I add here 2 pi plus 2 pi, tn kairi 2 pi plus 2 pi,
Okay.
4 pi. Again I add 6 pi. I add, what am I going to have? 8 pi. Again I add 10 pi. How do you find the scale? Any method, a simple method you know on how to find the scale. Hmm? Any simple method, but this is the simplest method I know so far. That one for saying divided by 2, it's a bit complicated. It's complex. Sure. Or it's because of the phase shift. If we didn't have the phase shift, we are supposed to end on 4 pi. Meaning we are supposed to have in that case, meaning I don't have in these brackets here. In short, when the phase shift is 0. I think I explained that. Okay, when I've got the phase shift, what it means is that the graph is supposed to start from here. But initially the graph was supposed to end on 4 pi. But because I've got this phase shift, that's why it's going to start from -2, and it's not going to end on 4 pi. Yes, yes, exactly. In that case, if you have the phase shift, forget about the period, meaning you're not going to use it. Yes,
Sam,
yes.
is it recommended that we should always reach 65 points?
Okay, why do I always say 5 points? Because the graph for sine, it goes like that. It goes like that, then it comes like this, eh? So you have the first point where the graph is starting from, the top part, again that part, also that part, and that part. That's why I'm saying is 5. Have you seen? Even for cos, we do use 5. Unless you have been told where you are supposed to end. If you have not been told, you are just interested in 5. That's all. Then now the vertical shift is at -2. Let's put -1 here, -2. That's where the graph will start. Like that. Meaning that I'm supposed, from this line, I'm supposed to move here. Let me put other points. I'll put -3, -4, -5, -6. Here I'll put 1, 2, 3. What does it mean? My starting point is now at -2. So from -2, my amplitude is 3. I need to move where it's going to end on top. I need to move 3 steps. So 1 from here, right? 1, 2, 3. So on top it has to end on +1. Down part from -2, I need to move 3 steps. 1, 2, 3, I'm going to end on what? Negative 5. So the graph has to start from this point. Okay, since it is positive, it has to go all the way, it ends there on 1, it comes back, it has to touch there, then it comes to negative 5 here, then again it goes there. So it will be like that. That will be my graph. Any question? Hmm? Any question, guys? Okay, let's have the last one, the one you have sent in the group. But now the problem is that the one you have sent in the group is the one which came in your exam, and we can't solve this. We have been solving this question for the past, no, it's different, right? Okay, it's different. Y is equal to 1 minus 3 sine 2x plus pi. So the question is, find the period and the phase shift. So the period, the PD, will be equal to 2 pi divided by b. B is 2. So the period is just pi. Because I've got the phase shift is not going to end on pi, so the phase shift is given by what is inside, equate it equal to 0. So for x, 2x is equal to negative pi, divide by 2 by 2, so x will be equal to negative pi over 2. That is my phase shift. The amplitude is 3, not negative 3. You get the modulus of 3. The modulus of A. So in that case, it's going to be just 3 if they ask you about the amplitude. The vertical shift is 1. Now I can sketch. What does it mean? Initially it was supposed to end on pi, but because there is phase shift, it's not going to end on pi. It's not even going to reach on pi, I think. If we see, I don't know, but let's see. The graph has to start from negative pi over 2. I keep on adding this. So what is negative pi plus pi? Is 0. The next point will be here. Then 0 plus pi over plus what? 0 plus what? Pi over 2 is going to be pi over 2. What will be the next point? Pi over 2 plus pi over 2. We're going to have what? Pi over 2 plus pi over 2 is going to be what? Pi. How many points do we have? We have got 4. We need to have 5. We need to have 5, but again the question here was, we need to end on pi. It has, okay. The question, we have been guided that the question is supposed to start from negative pi all the way to pi. So then this side I need to keep, okay, it's now making sense. I'll end there. This side now I'll keep on adding. Again, it's going to be what? I'll have negative pi here, because I'll say negative pi over 2 again minus pi over 2, which is going to be negative 2 pi over 2, which is negative pi. The question itself, the question which has been sent in the group, is saying sketch the graph for f of x is equal to negative pi less than or equal to x less than or equal to pi, meaning it's supposed to start from negative pi, again ending on pi. So we need to have 5 points. So you can clearly see here that I have 5 points. I have 1, 2, 3, 4, 5. But the starting point has to be, for me not to make any mistake, I have to start from what? From this point here. Okay? So the best thing here to understand this is that this is negative. Instead of this graph starting like that, it is going to start like this. It's going to open up and asking for money. It will open up and ask for money. So now the vertical shift is at positive 1. Let's put 2 here, 3 there, 4 there. Down here we put -1 there, -2 there, -3 there. So my oasis is going to start from there. I need to have a straight line. Like that. At 1. So from here I count 3 steps down, 3 steps out. Not so. So from here I'll count 1, 2, 3. Have you seen what I've done? Hello? Have you seen what I've done? So I'll end there. Down here from 1 here I'll count 1, 2, 3. I'll end on -2. In other words, the graph is going to be shifted 1 unit up. So now it's going to end on -2 down, on top it will be on 4. So I start from this point here, but it has to open up, asking for what? For money. So open up from here, it has to come here. Let me use different color. Starting from this point, it goes there, then it goes where? Again, from there it goes, it coming there, then it end there. Then here I'll just go there, and again I'll say it has to end where? It has to end here. So let me first graph this part. Starting from this point, okay, coming like that, it has to touch this point here. Then it will end there. Wait a minute, just pi over 2. Starting from here, okay, meaning when I come here, this has to come there. Then I'm supposed to, it can come like this. Then it goes, it touches there, then it goes there. This is the graph. I think, have you ever heard someone telling you to say there is a sine graph which comes out as a cosine? Have you ever heard of that? Okay. So then here now, since the graph, this is supposed to be the way it is, I can't continue here because I've been told that I'm supposed to end there. Then this side I've been told that it is starting at that point, but I've been told that I'm supposed to end at -pi over 2. So I can continue there and say it's going to come here like that. I just end there because I can't condense it. If I condense it, then I'm going beyond. So now if I get this part and that part alone, is going to give me a perfect graph. If I add that part which is here to this side, it's the same as it comes like that. So I think there's someone who asked me this question to say there is a graph for cos, for sine, but it comes out as a cosine. This is the graph. So the one starting from this point, it was wrong, because the starting point, always you start from the phase shift. So I've started from this point, going here, then I go there. So I end there because I've been told that I should end on pi. But even here I'll extend it because I've been told that I should end on what? -pi. Please ask now one more last question. Sorry. Uh-huh. Pi over 4. Which one is pi over 4, sir? Uh-huh. Uh-huh. Yes, it's 4. No, no, it's not going to touch there, but it is on the straight line with that. But it has to touch the bottom part because of this negative. The graph now is going like this. If it was positive here, it would have been starting from here, going like that. Then now, in a case where the same question, they just put modulus here. They just put a modulus. Meaning the part which is negative part here, with the part which is on the negative, you just refract it. It has to come on top. So it will come now on 2, like that. So it will be like that. It comes here. Then you put this in dotted. If there was a modulus. Any modulus, if they include the modulus, the part which is negative, if it was on negative 2, it will reflect on negative, or it will reflect on positive 2 on top. Guys, there is life after SAP. I'm